this video we're going to go over the electrical chemical cell potential. So we have a basic equation here of the cell, and it's the right hand side minus the left hand side. This will become a bit clearer in a second. The convention states that the right hand side of the cell reaction is always a reduction process. So if you remember oil rig, oxidation is loss, reduction is gain. So reduction, gain of electrons or hydrogen. And the left hand side of the reaction is the oxidation process. So if we do some examples, calculate the cell potential of the electrochemical cell below and write the overall cell reaction. So this is one way to write a cell. So we have zinc and copper. We have zinc on the left and copper on the right. So there's many ways to identify what is reduction and what is oxidation. One of the rows we just mentioned here, the right hand side of the reaction is always reduction. So we can tell that copper is on the right and copper would therefore be reducing. And then another way to identify is if you look at the electrochemical cells, their standard potentials, the higher of the two will be reduced. So here 0.34 is higher than minus 0.76, so copper will be reduced. As I mentioned before, oil rig, oxidation is loss, reduction is gain of electrons. So we know that the equation for copper, gaining electrons, will look something like this. And of course we have the stir symbols. And we know that zinc will be oxidation. So we have zinc, oxidation is loss of electrons, so it'll be Zn. And then you have Zn2 plus 2E minus. That's solid to aqueous. So that's how we identified how the general reaction was going to go. To calculate the cell potential, we have the equation here. This is always right minus left. So E cell equals right. So minus left. The left is zinc, which is 0.76. So minus minus is a positive. Like if we wrote it like this. So minus minus is a positive. Which equals 1.1, and that's in volts. So write the overall cell reaction. So here we basically align the two arrows and write everything on each respective side. So for copper, on the left hand side we have Cu2+, which is aqueous, plus 2E minus. On the left hand side of zinc, on this one we have Zn, which is solid. On the other side, if I draw an arrow, we have copper as a solid. We have, on the right hand side of this equation, the zinc ion and 2 electrons. Now if you see, we have 2 electrons on both sides, so they can cancel out because the electrons are getting transferred basically from this equation to this equation, so they're being transferred to each other. So the overall cell reaction is Cu2+, gives you Cus plus Zn2+. So you see the copper has gained the 2 electrons to become copper solid, and the zinc has lost 2 electrons to become zinc ion. So if we do another example, calculate the cell potential and overall cell reaction. This time we're just given the 2 standard cell potentials. So the cell potential is the right one minus the left. So we need to identify which one is right and which one is left. So one of the ways which I mentioned before how to identify is the one on the right is always the reduction process. The one that is being reduced is the one with the highest standard potential of the two given. So the higher one is nickel, because negative 0.23 is higher than negative 0.26. So nickel is being reduced and is being oxidized. So vanadium is oxidized. So we can write right hand side, which is reduced. So negative 0.23 minus, and then we have minus 0.26 from the vanadium. That gives us minus 0.23 plus 0.26, which is 0.03 volts. And it wants the overall cell reaction as well. So since we know nickel is reduced, so we have reduction. If something is reduced, it gains electrons. So Ni2 plus 2e. Do you see how the electrons balance? So we have 2 positive and we have 2 negative. That gives us Ni state symbols. And then if we do the same with vanadium, vanadium is oxidized. Oxidation is loss of electrons. So we have V2 plus, and that goes to V3 plus E minus, and think they're both aqueous. So if we look on either side of the equations, the charges balance. So we have 2 positive and 2 minus to get neutral, and this is neutral. We have 2 plus on here, a 3 plus, and 1 minus to cancel it out. Now to make the overall cell reaction, we need to balance the number of electrons, because like the previous example, the number of electrons cancel out. So if we multiply this equation by 2, we get 2v2 plus 2v3 plus 2e minus, then we can cancel them both out. So on the left hand side of the reaction, we would have Ni plus 2v, and then on the right hand side we would have Ni solid plus 2v. And as we can see, the charges balance. So on the left hand side we have 2 plus, and we have 2 of the 2 pluses, so in total 6 plus. And then on this side we have none for here, and 2 of 3 plus, which is 6 plus again. And that's it.